Lecture 3 Memory Systems. Outline of the chapter Memory Systems, Classification and Hierarchy of Memory Systems. Main memory, cache memory, secondary memory, other types of memory, memory management. Key characteristics of computer memory system: location, processor, internal, main, external, secondary, capacity, word size, number of words, unit of transfer, word block, access method, sequential, direct, associative, performance, access time, cycle time, transfer rate, physical type, semiconductor, magnetic, optical, magneto-optical, physical characteristics, volatile/non-volatile, erasable/non-erasable, organization. Unit of transfer, internal memory, the unit of transfer equal to number of data into and out of memory module. Word, natural unit of organization of memory, size of the word equal to number of bits used to represent a number and to instruction length. Addressable unit is word sum, system addressing, byte level unit of transfer, number of bits read out of or written into memory at a time. Methods of accessing: sequential access, start at the beginning and read through in order. Access time depends on location of data and previous location, e.g. tape. Direct access, individual blocks have unique address. Access is by jumping to vicinity plus sequential search. Access time depends on location and previous location, e.g. disk. Methods of accessing: random access, individual addresses identify locations exactly. Access time is independent of location or previous access, e.g. RAM. Associative access, data is located by a comparison with contents of a portion of the store. Access time is independent of location or previous access, e.g. cache. Performance access time, time it takes to perform read or write operation. For random access memory, time it takes to position the read-write mechanism at desired location. For non-random access memory, memory cycle time applied to random access memory consists of access time plus any additional time required before next access. Performance transfer rate, rate which data transferred into or out of memory unit. For random access memory. For non-random access memory, Tn equals average time to read or write, n bits, ta equals average access time, n equals number of bits, r equals transfer rate, in bits per second, bps, and plus equals. Physical type: semiconductor, RAM, magnetic disk and tape, optical, CD and DVD, others, bubble, hologram. Physical characteristics: decay, volatility, erasable, power consumption, organization, physical arrangement of bits into words not always obvious. G. Interleaved. Fic. Memory hierarchy in a computer system. The memory hierarchy. 11. The memory hierarchy. Hit vs miss. Hit: the requested data resides in a given level of memory. Miss: the requested data is not found in the given level of memory. Hit rate: the percentage of memory accesses found in a given level of memory. Miss rate: the percentage of memory accesses not found in a given level of memory. Hit time: the time required to access the requested information in a given level of memory. Miss penalty: the time required to process a miss replacing a block in an upper level of memory. The additional time to deliver the requested data to the processor. Hit vs miss. Memory hierarchy. The memory hierarchy relationships: faster access time, greater cost per bit, greater capacity; smaller cost per bit, greater capacity; slower access time. As one goes down the hierarchy, the following occur: decreasing cost per bit, increasing capacity, increasing access time, decreasing frequency of access of the memory by the processor. The memory hierarchy registers in CPU. Internal or main memory may include one or more levels of cache. RAM, external memory backing store hierarchy list registers: L1 cache, L2 cache, main memory, disk cache, disk, optical tape. Main memory. The main memory is the central storage unit in a computer system. It is a relatively large and fast memory used to store programs and data during the computer operation. The principal technology used for the main memory is based on semiconductor integrated circuits. Integrated circuit RAM chips are available in two possible operating modes: static and dynamic. Bootstrap loader. It is ROM portion of main memory which is needed for storing an initial program. It is a program whose function is to start the computer software operating when power is turned on. The startup of a computer consists of turning the power on and starting the execution of an initial program. RAM and ROM chips. Typical ROM chip. Memory address map. Memory connection to CPU. RAM and ROM chips are connected to a CPU through the data and address buses. The low order lines in the address bus select the byte within the chips, and other lines in the address bus select a particular chip through its chip select inputs. Memory connection to the CPU. Semiconductor memory types. Memory type category. Erasure write mechanism. Volatility. Random access memory, RAM. Read-write memory. Electrically, byte level. Electrically volatile. Read-only memory, ROM. Read-only memory not possible. Mask. Non-volatile programmable ROM, PROM. Electrically erasable PROM, EPROM. Read mostly memory. UV light, chip level. Flash memory. Electrically, block level. Electrically erasable PROM, EPROM. Electrically, byte level. RAM misnamed as all. Semiconductor memory is random access read/write. Volatile stored data in MBs. Temporary storage. Static or dynamic. Require periodic charge refreshing to maintain data storage. ROM stored data in GBS. Non-volatile. Read-only. Permanent storage used for startup process in computer. Writing data is slower. SRAM bit stored as on/off switches. No charges to leak. No refreshing needed when powered. More complex construction. Larger per bit. More expensive. Does not need refresh circuits. Faster. Cached RAM. Read-only memory, ROM. Permanent storage. Applications. Microprogramming library. Subroutine systems. Programs, BIOS, function tables. Problems. Data insertion step includes large fixed cost. No room for error. Written during manufacture. Very expensive for small runs. Programmable ROM, PROM. Non-volatile and written only once. Writing performed electrically and may performed by supplier or customer after original chip fabrication. Needs special equipment to program. Electrically erasable PROM, EPROM. Takes much longer to write than read. Advantage. Non-volatility and being updatable in using ordinary bus control, address, data line. Refreshing. Flash memory. Erase whole memory electrically. Entire flash memory can erased in 1 or few seconds, faster than EPROM. Possible to erase just blocks. Impossible to erase. Byte level use. Only one transistor per bit. Achieves high density. Refresh circuit included on chip. Disable chip count through rows. Read and write back takes time. Slows down apparent performance. Auxiliary memory. Information organization on magnetic tapes. The most common auxiliary memory devices used in computer systems are magnetic disks and tapes. Associative memory. Accessed by the content of the data rather than by an address. Also called content addressable memory, CAM. Hardware organization. Fig. 1 cell of associative memory. Cache memory. Cache stores recently used data closer to the CPU. One miss may lead to multiple hits. Locality. Locality of reference. The references to memory at any given time interval tend to be confined within a localized areas. This area contains a set of information and the membership changes gradually as time goes by. Temporal locality. The information which will be used in near future is likely to be in use already, e.g. reuse of information in loops. Spatial locality. If a word is accessed, adjacent, near, words are likely accessed soon. Cache memory. Spatial locality. If a word is accessed, adjacent, near, words are likely accessed soon, e.g. related data items, arrays, are usually stored together. Instructions are executed sequentially. Cache. The property of locality of reference makes the cache memory systems work. Cache is a fast small capacity memory that should hold those information which are most likely to be accessed. Cache memory. The basic characteristic of cache memory is its fast access time. The transformation of data from main memory to cache memory is referred to as a mapping process. 3 types of mapping procedures in organization of cache memory: associative mapping, direct mapping, set associative mapping. Associative mapping. Any block location in cache can store any block in memory. Most flexible mapping table is implemented in an associative memory. Very expensive mapping table stores both address and the content of the memory word. Direct mapping. Each memory block has only one place to load in cache. Mapping table is made of RAM instead of CAM. N-bit memory address consists of 2 parts, K bits of index field and NK bits of tag field. N-bit addresses are used to access main memory and K-bit index is used to access the cache. Direct mapping. Addressing relationships between main and cache memories. Fig. Direct mapping. Cache organization. 39. 40. Bits in the main memory address are divided into 3 fields. Word identifies specific word in the block. Block identifies a unique block in the cache. Tag identifies which block from the main memory currently in the cache. Consider, for example, the case of a main memory consisting of 4K blocks, a cache memory consisting of 128 blocks, and a block size of 16 words. Show the direct mapping and the main memory address format. 43. Advantage: easy, does not require any search technique to find a block in cache. Replacement is a straightforward. Disadvantages: many blocks in are mapped to the same cache block. We may have others empty in the cache. Poor cache utilization. Fully associative mapping, allowing any memory block to be placed anywhere in the cache. A search technique is required to find the block number in the tag field. We have a main memory with 214 words, a cache with 16 blocks, and blocks is 8 words. How many tag and word fields bits? Tag field requires 11 bits. 214/8 equals 2048. Blocks word field requires 3 bits. Fully associative mapping advantages: flexibility utilizing the cache. Disadvantage: required tag search. Associative search. Parallel search might require extra hardware unit to do the search. Requires a replacement strategy if the cache is full. Expensive. Cache replacement policies: random simple requires random generator. First in first out, FIFO. Replace the block that has been in the cache the longest requires keeping track of the block lifetime. Least recently used, LRU. Replace the one that has been used the least requires keeping track of the block history. Cache replacement policies: most recently used, MRU. Replace the one that has been used the most requires keeping track of the block history. Optimal hypothetical: must know the future. Set associative mapping: each memory block has a set of locations in the cache to load. Set associative mapping: cache with set size of 2. Set associative mapping. Cache write through when writing into memory. If hit, both cache and memory is written in parallel. If miss, memory is written for a read. Missing block may be overloaded onto a cache block. Memory is always updated. GT important when CPU and DMA/IO are both executing. Cache write back, copy back, when writing into memory. If hit, only cache is written. If missing block is brought to cache and write into cache for a read. Candidate block must be written back to the memory. Memory is not up to date, i.e., the same item in cache and memory may have different value. Virtual memory: give the programmer the illusion that the system has a very large memory, even though the computer actually has a relatively small main memory address space, logical, and memory space, physical. Address mapping: memory mapping table for virtual address. GT physical address. Secondary memory, primary memory. Secondary memory: fast, expensive, low capacity, connects directly to the processor. Slow, cheap, large capacity, not connected directly to the processor, where programs and data are kept on a long time in a computer. Secondary memory is a memory where programs and data are kept on a long-term basis. Common secondary storage devices are the hard disk and floppy disks. Memory management: it describes how operating systems handles the available memory and managed by multiple levels. Techniques of main memory, paging and segmentation. Basic functions of dynamic storage: relocation mapping, logical memory references to physical memory references, provision for sharing common information stored in memory by different users, protection of information against unauthorized access. Segmentation: a segment is a set of logically related instructions or data elements associated with a given name, variable, size. A memory management scheme which supports users' view of memory. A logical address space is a collection of segments. Each segment has a name and a length. Address specify both the segment name and the offset within the segment. For simplicity of implementations, segments are numbered. Memory protection: the protection field in a segment descriptor specifies the access rights to the particular segment. In a segmented page organization, each entry in the page table may have its own protection field to describe the access rights of each page. Access rights.